సెట్ చేసుకోవా?
అన్నీ తీసుకుంటాం ఒకసారి.
కొంచెం లేకపోతే దగ్గర పెట్టుకుంటావా?
కేబుల్ వస్తుంది, అటు ఇటు వెళ్తున్నారు.
So yeah, welcome back everyone. Did you have a good break? Yes. So let's have a quick fun activity.
Mobile it is.
Alright.
Someone given
somebody else's mobile.
Yeah,
You are not to go on your mobile.
No, someone given the
Just put
sorry,
your
I
own
need that.
attention
You want-
here, please, for some
Group photo जो
time.
mobile पे लिया ना किसी ने, I need.
I'll arrange it.
Okay. So I want 5 people among you. Any 5 would love to voluntarily come here for the activity, and whoever the winner will be getting the goodies at the end of the event. Okay?
కొంచెం
Finish
ముందు
that?
పెడదాం, కొంచెం
We
ముందు
can
పెట్టుకో.
just do
జూమ్
a
చేసుకోవచ్చా
quiz
లేకపోతే
sort of a
కొంచెం
thing.
జూమ్ చేస్తే ఏమన్నా
So, any 5
కెమెరా
from you?
వచ్చి
Okay, I could see people coming. Yes. Okay. On the stage, please. Yes.
లోగోస్ వేయచ్చా? ఇది స్క్రీన్
Okay.
దీని మీద ఫ్రేమ్ యాక్చువల్ ఫ్రేమ్ పెట్టచ్చు.
Okay. Okay. Okay.
ఫస్ట్
Ready
మనం
for-
ఫ్రేమ్ పెట్టుకోవాలి.
ముందే పెట్టుకోవాలి.
Goodies are good bribe. Okay.
లైవ్లో అదే ఫ్రేమ్ పెట్టాలి.
Alright, that's fine.
నేను వీళ్ళు ఇస్తున్నారేమో అనుకున్నాను, నేను మర్చిపోయాను. ఇక్కడ ఫ్రేమ్ వస్తుంది యాక్చువల్లీ అంతా. ఇక్కడ పెట్టుకోవచ్చు. ఇక్కడ ఆప్షన్ ఉంది కదా యాక్చువల్లీ.
ఇప్పుడు పెట్టడానికి కావాలి.
I need you here for the rescue, please.
ప్రాపర్టీస్
ఇది నా కూడా కొత్త.
And we'll do the activity. So this activity is going to run behind. Okay. I'm going to ask them questions that you are going to hear it later. So let me do some activity
కొంచెం
then
ముందు పెట్టు.
with them first.
1 feet. కాకపోతే ఇక్కడ పెట్టుకుంటాం. ఇది ప్రాజెక్ట్ దీని పక్కన పెట్టుకోవచ్చు కదా. నీకు కొంచెం ముందుకు వెళ్తుంది, అడ్డం కూడా ఉంటుంది. కొంచెం అనుకో.
I guess you're doing some treasure hunt, maybe. Looks like so, right?
Okay.
So I'm making them do some activity, so which will be revealed soon to you guys as well. So meanwhile, requesting to the participants who are in the track 2 to please join that.
I don't know.
Looks like some conspiracy happening here.
ఒకసారి లైవ్ వస్తుందో చూడు. మొత్తం
రికార్డ్ కూడా అవుతుంది కదా ఆటోమేటిక్గా.
దాంట్లో రికార్డ్ చేస్తున్నారు.
రికార్డ్ చేస్తుంది. జాగ్రత్త, కెమెరా దగ్గరే ఉండు. అది తనేసారు అనుకో.
ఇందులో కూడా చూసుకోవాలి.
ఇందులో మనోడు చూస్తాడులే. ఇప్పుడు తిరుగుతున్నారు కదా ఈ 10 నిమిషాలు అక్కడే ఉంటారు.
Requesting the participants, whoever is in track 2, please join track 2.
SRE ఈవెంట్ అని చెప్పి SRE చంద్ర గారు మీడియా అని చెప్పచ్చు, మార్కెటింగ్ టీమ్.
Alright, we are done whatever we're doing. So there was an activity going on. So these were the participants for the activity, and whoever is going to win this, so will get a goodie. Alright, so now let me reveal the questions that I've asked them. Let me see how much our audience can answer correctly. I request the participants to please, keep the checks with you first. Okay? So as soon as I prompt the question, you just have to, raise the hand first and tell the answer loudly. Let us see that you can match with the audience or not. Let us see the audience can, be more accurate than them or not. Okay? Okay, Mike. Please check. Is that working? Is that okay? Okay, just be louder. How many characters and stories did Vinay say in the presentation? Oh, okay, that's great. Please let us give a huge round of applause for them. Okay, alright. The next question is, how many of you remember all panelists' names and name them?
కొంచెం లేట్.
నాగార్జున, జ్యోత్స్న, వినీత, శివసుబ్రహ్మణ్యం,
విష్ణుప్రియ అరే
విష్ణుప్రియ.
Yes. Okay, well said. Okay, great. So, audience, already forgot about it. Break में सब भूल गए? Coffee पीते पीते. Okay, great. So the last question is. I asked you. You can't note it down. Put your pens down first. Okay, who is the panelist who speak about the Chuck review? Great. So we just had a session now. So let us proceed towards our session back. Shall we? How's the Josh? What is this? How's the Josh? Okay. I need more energy. Alright. Thanks all. Please submit your answers and please submit it. ready? Yeah. So yeah, welcome back everyone again. So, because we have got some fantastic speakers lined up this afternoon, I need your all energy till the last session. Alright, so and we are kicking things off with someone who is known across the cloud native community by a name many of you may already know. It's Maharaj. Now that's a nickname that immediately gets your attention because when someone says Maharaj is speaking, you don't ignore that session. Known across the cloud native community as Maharaj, our next speaker has a rare talent. He can take complicated technology, complex platforms and challenging engineering concepts and explain them in of the cloud native world. Starting his journey in QA engineering and growing a principal developer advocate, he has built a reputation for combining deep technical expertise with storytelling that connects with people. And today, he's here with me during lunch. So the title is Why Your Developer Platform is Making Your SRE's Life Harder. So this is the title. Now, as the title is definitely getting your attention, ladies and gentlemen, please put your hand together for Atul Priya Sharma Maharaj. Alright, so Atul, I just want to have a quick thing with you before I give you the mic. So what is the new food or casino restaurant that you explored?
So I'm going to there's a new Thai restaurant that has opened in Knowledge City. So I'm going there today evening. So thanks for saying such beautiful words about it. Cool. Welcome back after your chai and coffee break. Before I begin, there are a couple of disclaimers that I want to give you all before I start talking. The first one I'll ask by quick show of hands. I know it's a wrong question, but how many of you are SREs over here? Quick show of hands. Okay, cool. Anyone from the SRE Hyderabad community over here? Quick show of hands. Okay. So, why I'm doing this is I'm not an SRE, that's a disclaimer. And whatever I'm going to talk today is vetted by these guys from SRE Hyderabad. So I remember about a month back, I got hold of all of them and I asked them first to validate my use case if it is correct or not. And those guys told, yeah, absolutely that is correct. So in case anything goes wrong in today's talk, if the question. The second one, quick question again, how many of you all want to see AI here in this talk? Yeah, AI? Cool. This is the only AI slide that's there in this talk. That's the only AI that I'm going to talk about. You can see Gemini logo over there and that's it. So this is not going to be an AI talk for a change. You will have a lot of exciting AI related discussions that will go on. So, what is based on what I know? And what happens when you visit a typical restaurant? You visit a restaurant, you go to the menu and then you probably ask the server that, hey, these are the things that I want to order. And once you do that, the server will take your order to the chef. The chef is going to start preparing your order based on whatever you have ordered. It could be a biryani, it could be a kubani ka meetha, etc. etc. The server then gives the food to your table and you are too excited, your mouth is already watering to try whatever is coming in. He serves, you are just amazed by the aroma of the food that is on the table. But the first bite you take it, you are like, ye kya banaya hai? How many of you have had that experience ever? That you get something on the table and you are like, what is this? Right? Some of you, so you can relate to it. You suddenly eat it and then you are like, what the hell is this? I was not supposed to be eating this. Ye biryani hai kya? Isse acha to main ghar pe banata karke. You do that and then you scold the server. And the server is like, why me? I didn't cook the food. The food was prepared by someone. I just brought it to you. But you are firing me. Why? And if you just flip the scene, that's exactly what happens in the office as well, right? You have the development team who is very happy because their deployment was successful. They pushed out a feature, deployment rolled out perfectly, no errors, everything green. But your users, they are not able to access the application. And then you have your SRE team in between. They are like, why me? I didn't build the app. I don't know anything about it. And I am the one who is responsible to ensure that this thing is running without having any context. So that's exactly what I'm going to be touching upon today. She already gave the title of the talk. So we'll be touching upon why your developer platform is making your SRE's life harder. Quick introduction about me. She already said a lot of things. But yeah, I'm based out of Hyderabad. I'm Atul. And I work as a principal developer advocate at Improving. I've been the co-chair of KubeCon India that happened in Hyderabad last year. I'm a CNCF ambassador and I run the Cloud Native Hyderabad community with some amazing co-organizers there. My areas of expertise include platform engineering, DevOps, developer relations and Gen AI. It's there because people want to see Gen AI. If you want to know more about what I do, that's my QR code for the LinkedIn. You can check out and understand everything that I am doing at a professional level. Talking about the community, we spoke about the Cloud Native Hyderabad community that I am a part of. We have started this community in 2019. And again, the goal of these events is to ensure that free learning is provided to everyone within the city, within the country, within the globe as well. So those are our social handles. You can join the community here. The next meetup that we are doing as a community is on July 25th, and the focus would be on Gen AI and observability. So if you are interested to join the community, you will get more updates on when and where the meetup is happening. Now, outside of work, I have a different avatar. Maharaj is the nickname that I go with online, and when I'm not coding or not speaking about anything tech, I am a food and travel content creator. I enjoy cooking, I love traveling. Those are some photos from my recent trips. If you want to keep up to date in terms of which restaurant to go, what things to try, that's my Instagram page. Trust me, you'll get some good information over there on where to find your next meal. So, before we get in, let's see the journey of how things happened from DevOps to platforms. So, the original thesis was, developer teams are building features fast and they had to be deployed at some place. And the idea of Dev and Ops and DevOps together was that the Dev team focuses on whatever the development is happening, and our Ops team ensures that everything is stable, that your applications are deployed at the correct place, they are available, they are reliable. Now the problem over here was there were conflicting incentives for everyone. While the Dev team was asked to be shipping faster, the Ops team was tasked to ensure that your applications are reliable and applications is healthy, it stays healthy, it's accessible by a lot of people. And because of this, what happened? Your releases got slower and slower. So DevOps basically merged both of these two and it broke the wall. So it never happened that it doesn't work. It works on my machine, that problem was gone because DevOps came in. So you're not throwing things to different teams. And then the entire team had one goal, which was ship and run as one responsibility. That's what DevOps got in. Now, DevOps was more cultural and it didn't focus too much on the operational bit of it because as it is, there were tools to get things done. But it was more about the philosophical change that was needed on how do you change the process, how do you build your applications, how do you deploy your applications. And that's what it was. And that's when around that time, Google asked the question, what if Ops was software engineering? And that's where the SRE runbook came into the picture, where they decided all the principles around how your application should be maintained, your reliability, monitoring, everything else. So SRE added the rigor to the entire DevOps process that was there. So they were the ones who discussed with the teams, came up with the SLOs, decided the error budget, and they ensured that there was less of a blame game when anything happened. They are the ones who kept an idea, who had the inputs on what the application is, what are the required things to ensure that the application's uptime is high, and they focused on that. So eventually what happened was that because of the SRE practice coming in, your reliability became a measurable impact now. So previously it was just like, my app should be running, but now it's like, is it 4 nines, is it 5 nines, is it 6 nines? Those things came in when the SREs came into the picture. Now, why platform engineering happened? So for everyone else, I speak to, as a layman, I would say platform engineering is a DevOps Pro Max, if that's the language everyone understands, because platform engineering is exactly doing that. So while developers focus on building and shipping features, the SREs focus on the reliability. The platform's focus over here was to ensure that both of them do their job, everything else is taken care of by the platform. So if a developer wants to deploy a microservice to a particular environment, the developer need not worry about where is it going, what is the memory requirement needed, what GPU should I be hitting, nothing. That's the work of the platform team. So that's exactly what platform engineering does. So you have 3 roles, you have one production system, but all of them were targeting a common problem, and platform engineering was there to solve that. How many of you all know about platform engineering here? Quick show of hands. I know there is a platform engineering leader here, and that's why I was nervous that I'm talking to a platform engineering leader here, but I see quite a few hands, so we'll do a quick recap on what exactly platforms are. So the whole idea, while there is content on the slide that you can read, the whole idea of having platforms was that you allow your developers to focus on what their task is, which is building features and shipping features. Everything else has to be taken care of by the platform. So what are these things? It could be guardrails that we speak about. So you want your developers to ensure that certain security practices are always followed. So you build a platform, and platform builds the gates and ensures that every developer who is deploying an application, deploying a workload, will automatically follow it, because your platform becomes the central point of enforcement. Yeah, that's the word. So whatever things that you do within an infrastructure, within a lifecycle which is repeatable, platform took that from the developers, and it was the platform team's responsibility to build these premises and let the developers just do a bunch of clicks and their applications will be deployed. Now, how this was actually done. So there are a few terms that you will come across that is thrown around when it comes to platform engineering. Golden paths, I'll talk about it more. Self-service model, guardrails, and all these 3 are like the major terms that come in when you speak about platforms. And some of the popular tools that actually help you build platforms, open source, Backstage is a very popular tool that allows you to build your platforms, your port, and there are similar other tools as well. So, like I said, the whole idea of platforms was to reduce the cognitive load that the developers have. So they had to previously remember, the instance where it has to go, the IP addresses, the routing configs, the memory, all of this apart from the business logic of the application. So platform abstracted all of them. So we create one single path. So let's say if there is a big team of, let's say 10-15 developers working on a particular microservice for a particular language, you don't need to remember that, hey, this is the thing, or this is the microservice and this needs to be deployed at what particular place. The platform defines it. Every developer within the team uses the platform to deploy the service, which means there is consistency, there is standardization, everyone follows the same particular concept, same construct that the platform team set. So it's like you want to spin up a particular service, we have a golden path that is made for you. Golden path is basically a set of rules, pre-approved tasks. So let's say you want to deploy a microservice, the golden path that would be created for this would be that you need to specify the name of your service, you need to specify the geo where it has to be deployed, you need to probably specify a particular endpoint, and everything else like the memory that is required, the region where this will be deployed, the uptime, the availability, all these things will be defined by the platform. So platform actually abstracts all of this from the developers. So as a developer, you will set only 3 values, but eventually when this is deployed to a cluster or to production, you will see that there are 15 other values that were added, and that was done by the platform team. So that's exactly what a golden path is. So the platform team creates a golden path, everyone else within the team follows that path to deploy that particular service. Eventually what happens is, everyone who has deployed that service will be exactly the same. They will be using the same repos or libraries or modules, they will be having the same memory usage, they will be having the same GPU usage, everything remains same. To know more about golden paths, I know I can go on and on. This was a talk that I gave at KubeCon in Amsterdam in March. It's a blog post written out of it. So if you all want to know more about what golden paths are, how to build a golden path, how do you start building a golden path, to eventually putting it at a portal, That's the QR code which will take you to the blog post which has all the details, the code samples and everything related to it. So one was the golden path. So we are all clear, I assume, with the golden path concept. Next is self-service. Platforms also enable self-service. Now what happens is, let's say you want to deploy, let's say you want an EC2 instance for your service that you want to deploy. Traditionally what you will do is you will probably raise a ticket in some portal. That ticket will go to your IT team. Your IT team guy has gone to Tirumala for a week, so you will sit and wait for your ticket to be resolved. Only when he comes back from Tirumala, your ticket is approved and you get an EC2 instance. So for something that should have taken 5 minutes, it has taken 1 week because it was dependent on a person who was sitting there. What self-service does on a platform is, as the name says, it's self-service. So anything that the platform team and the larger team figures out that, okay, these are the things that can be done in a faster way, in a more reliable way, in a more self-service model, are provided as a service through the platform. Now that's exactly what self-service does. So if anyone wants any instance or a database or something, they go to the portal does the thing, they probably click a few buttons and they have the entire thing assigned. Now in this entire thing, there is no SRE in the picture. So everything that a platform does is for a developer. So the developer focuses on building, have golden path so that developers build something that is standardized, have self-service so that it's easy for the developer to build stuff. But where's the SRE in this? The entire thing around platform engineering, I lead the global platform engineering community at the CNCF. All discussions happen around developer productivity, DORA metrics, space metrics, everything. But where are the SREs in this mix? So it's like the whole premise here is that platform benefits everyone but not the SRE teams. And in typical SRE day, that's what happens. Something goes wrong, you get a threshold is hit, you get a page and something starts. You go through what the error is, you check who the owner is, you will scramble around to figure out who has deployed this application, what was required, why this is here. There was no SLO, there was no baseline, there is no way to know what has actually happened and why this thing is. You probably set up a war room, you try to reach out to a lot of people, and then eventually you realize, okay, I'm reaching out to the wrong person, and then they keep throwing you around unless you find the actual team owner who is supposed to be owning that application, and it will be like, oh हाँ ये तो default value थी. Just to listen to that at 2 AM or 3 AM in the morning that it was a default value, you spend so much time because you didn't have that particular answer with you when the incident occurred. So where do we fix it? And that's where I'm going to talk about how platforms come into the picture. Since a lot of you are SREs, I assume that all of you would have read about the Google SRE handbook. If not, please go and read it. It's a very good starting point to understand what SRE role is and what the work is. So Google's SRE book already mentions something called as production readiness review. So it's a manual checklist every time that you follow before a deployment or a release is done. And this practice has been documented in a lot of companies, organizations already follow it. But the problem with this is usually a manual checklist. So a lot of times you would probably not focus on it because on speed, you want to get some things out faster. So you'll probably ignore a few things, you'll miss on a few things. A lot of human factor involved in it. Plus, this entire PRR step is a separate process. It's not integrated to your existing software development and deployment process that exists. So a lot of the teams, what they do is, they will run the PRR thing once, they will set meta services, meta description about whatever they are deploying, and done. So that's the status coming in from Port.io's State of Internal Developer Portals report, where 53% of the team, they just update the service details once and they don't do it ever again. So that's the problem with the PRR. So let us fix it in a platform. Like I said, platform gives me guardrails, it gives me golden paths. So let's say this is a golden path, or this is a guideline that I have defined for a developer, that this is how you deploy an application. So what you see here is a YAML config file to deploy an Nginx application with the name and the port. These are the few things that I'll ask the developer, that you provide me these values, your application will be deployed. What we want to do is, along with this, we want to attach the operational context for our workloads that we are deploying. So you would want the developer to define who the owner of this application is, what's the email ID, what are the SLO targets, what are the memory requirements, what is the reasoning, what is the runbook URL. You want all these things to be provided when the workload is deployed. So all these things will be specified by the platform. So the developer would essentially still give those three things, name, image and port. but everything else is added by the platform. Why? Because you need this context when an incident occurs. So there's a demo with this. There's a QR code to my GitHub repo. It is a public repo. I just made it public a while back. So you can, whatever I'm going to show now, it's there in this repo. It's a standalone single script that does a bunch of things to show exactly how a platform can enforce what is required to be done. So what I do is I'll just so this is a hypothetical incident portal, which I'm sure you would have seen, PagerDuty or anything. This is how a particular incident portal looks like. And it says right now that it is going to wait for a deployment. If you come here, let's add a deployment over here. So it's basically an Nginx application that is being deployed onto a cluster, and when the state is healthy, the dashboard shows me exactly what the application is deployed. Let's go ahead and inject an error. So now when an incident occurs, you will see that the status goes to crash loop back off. There is some error here. But for an SRE team, this is the only information that I have. I have no idea what the error is, why this has happened, what is the SLO supposed to be, what are the targets, who is the owner, none of it is present. So that's what we'll ask the platform to enforce. And if you see here now, let's go ahead and... So let's say now we ask the developer to deploy their workload now. If you see, the platform has already flagged saying that you are missing those 6 items that were supposed to be given. So until unless this is not done, the application will not be deployed. So this is the exact context that we are trying to add over here. So once the developer fixes it, Yep. Now when the application is deployed, you will see all the details like owner, on-call, whatever details that are required, alert is fired when, what are the memory limits. So this is the context that the SRE team will get. So the whole idea of today's demo, and it was a very short one, was basically that the platform that we are building, which focuses so much on the developers, there is going to be a very minimal effort that is required to add more context for our SRE folks. All you need is just sit with the teams when you're building a platform, think of the platform as a product, bring in all the stakeholders while you're building the platform, and ensure that whatever context is required, you are adding that context in the platform itself. So when an incident occurs, your SREs already have all the details that they need to figure that issue out. So yeah, that's all I wanted to talk about. No AI, very simple, I tried to keep it. But then yeah, if you all want to discuss more about platforms or understand more about the code, what it was doing, what the files were, and be around the entire day, you can reach out to me. There's my LinkedIn again if you want to continue the discussions over there. I'm sorry I took a few minutes extra, but I think that's okay. Thank you so much.
Let's hear it once again for Atul Priya Sharma Maharaj. Thank you, Atul Priya. What a fantastic session, I must say. You know one thing, one of the things that I love about technology is that every few years, someone comes along and says, this changes everything. And somehow, a few years later, someone else comes along and says exactly the same thing. So which is why experience matters, because while trends change, buzzwords change and technologies change, experience gives you something different perspective, and our next speaker brings plenty of it, 3 decades of it. Over those 3 decades, he has worked across project delivery, product engineering, technology solutions, and large-scale practice development. He is a respected technology leader at Tech Mahindra and has helped organizations embrace cloud technologies, digital transformation, and innovation at scale. He is also a strong supporter of technology communities and knowledge sharing, helping others learn from the lessons he has gathered throughout his career. And today, he is talking on a topic that I think all of us can appreciate. The title is addressing the gaps between theoretical promises versus practical outcomes of SRE practice. Because sometimes the promise sounds amazing and then reality asks a few follow-up questions. So ladies and gentlemen, please put your hands together for Chakravarti Komaravolu Chakri. Please, Chakri, the stage is yours.
Thank you. That was a wonderful introduction. I think, thanks Adul for the energetic presentation. You are setting the benchmark. And I noticed that he has also taken a poll of how many of you are actually SREs. I also go with the disclaimers what Atul was saying. I'm not a core SRE, but I do understand the importance of SRE in a business scenario. So most of my experience has been with an SI organization like Tech Mahindra. And most of my interactions have been with global enterprise customers, large scale. So with that, how SRE plays a role in adoption in those enterprises, and what are those gaps, and how do they actually can fill, is the topic for my session today. Is the audio okay? All right. So we'll start with some invocation and some prayer and bhajan. Is that okay? Not actually. Nothing to do with the prayers, nothing to do with the religion. Don't mind only picking the Hindu specific picture. But how many can recognize and relate to this picture? Bhagavad Gita. Good. And what is the context in which this was disclosed? It is a war situation. Correct? So why it is delivered in a war situation? Anybody thought? And and anybody has any idea of how many verses Bhagavad Gita has? Okay, 700 I heard. Very good. I think there is an extended version also. It goes beyond, I think 900 or so. So 1000 verses for someone to chant, it will take at least 1 hour. The fastest way, right? And in a war situation, you are spending 1 hour and also debating. There is a Q&A. There's so much of understanding, digesting, and then asking questions. So, in a war situation, do you really spend that much time? What Krishna was doing is actually addressing the root cause. Why Arjuna is not prepared to fight, right? It is not about just go and fight. Okay, I'm telling you, just go and fight. He could have done that, right? But he did not do that. He went actually into the root cause. What is the backdrop of this? What is the context in which this guy is depressed and emotionally imbalanced, etc. Right? So he is addressing so many root causes. That's something I thought is very relatable to SRE, number one. And number two, in this session, I am the Arjuna. Okay, I'm still a student of SRE. I'm still learning a lot, and that will continue also with the advent of AI coming into picture. Okay, now let's get into the topic. So SRE does a lot of promises. I'm not going into the laundry list of that, but at least the top 5, right? So the very first one is perfect balance between speed and stability. How many actually can understand this statement and relate to that on a day-to-day, activities? The speed we are talking about here is a speed at which a new features can be introduced into production. And as you increase your velocity of features, you are introducing instability into the system also. So it's like a nice balance, right? How fast you go and release versus how stable the system can be. You need to really strike a nice balance. So SRE says that if you follow the principles of SRE, you will strike the balance very well, the perfect balance, right? That is the first point. Second point is decoupling the business growth with operational overhead. Okay, what it means is the business is growing, okay, and if your operational overhead to support the system, that's not the best equation. For example, you want to support 1 million equivalent business with 10 people, okay, and you want to grow 10x. 100 million business also is supported with 10x of people. That's not the best equation. You want to keep the operational cost at the lowest possible thing while the business continues to grow, right? That's the second point. And SRE actually does the promise how this can be achieved. We will see in the following slides. The third point is business aligned observability. Now, what is observability for us? Observability is collection of your application data, your infrastructure data, your network data, security data, all that put together one single pool of data is observability, right? So-called observability platform. Now, how much of business context it has? Okay, let's take a simple example, right? A e-commerce platform where there is a just pass-by shopper also visiting the website versus a premium customer who is actually filling the cart with at 10,000 rupees worth of items. And in both the scenarios, if there is a failure occurs, who would you attend to first? Obviously, you need to prioritize. But observability doesn't tell you which customer issue is more important to you, right? So there is no business context in the observability. How do we really address that? So SRE again principally tells you how to really bridge this gap, how to bring the business context to the observability data, right? So fourth point, you can actually stop me in case you have any questions, that's okay. We will try to see how to manage the time, okay? Now fourth point is about safeguard the revenue from deployment failures, okay? So we are talking on the first point about velocity of deployments, right? While you do the deployments, if the failure occurs during the deployment, a failure is equal to a business loss. Business loss equal to a impact on the revenue, right? So how do I really safeguard my revenue while I do the lot of development and deployments? How do I make sure my revenue is zero or nullified? And SRE actually gives you the methodology, okay, to address that part. And finally, resilient systems through a balanced concept, or what is it? Blameless culture. Sorry. So I think some of these topics are well touched in the panel discussion also, but we will see how those can be deep dived into some of the aspects, how to take it forward in practice. Any questions so far? Are you guys aligned with these 5 points? Okay, I see some nods, I see a lot of silence. I'm hoping everything is digesting. Okay, now let's look at the promise number 1, perfect balance between the speed. So how do we do it? We do it using the error budgets. What is error budget telling me? I'm assuming, okay, there is an assumption that you guys are all aware of the basic terminology here. So error budget tells me that what is the allowable downtime in a given month, right? So how many times I can afford to fail as I go forward. So that is what is error budget. Now, within the budget limit, so every time I fail, I'm consuming certain budget and some burning out the budget, right? But as I afford to burn certain, failures or certain budget, I can progress and continue to push my deployments, right? In this way, by setting a budget, error budget, I am actually allowing the developers to launch the deployments faster, right? So that is the principle. But Is it practical? What you are seeing on the chart left side is, on theory, that's exactly the topic, right? The theory promises that you can do a balance. That assuming that a perfect balance is 100% score. The best of the best SRE organization is only 80%. Okay? And most of the Fortune 500 organizations, the average is close to 50 or even below the 50. What does it is telling? Even if I have a best practice of setting the error budgets, I may not actually maintain the balance of speed versus stability. There are reasons for that, okay, why it is actually coming down from a theory. There are gaps, which you can see on the reasons for the gap, velocity drop between. So any application to be set up, right? I need to set up the the monitoring elements, the observability, the automation, all those things. The setup that takes engineering effort, we actually bring down the balance that I actually wanted in the production system. So to prepare the ground or the platform that Atul was talking about, for every application, every system, there is a platform engineering effort that goes into so that the scale up can happen. So that actually causes a slowdown before I scale up, right? And similarly, budget trade-off. So how much I can do the balance? For example, the last mile, right? The minutest of effort, if I have to address, or avoid that kind of failure, 99.9 is equal to some 45 minutes of downtime in a month. That's what the equation comes out to be. How, I can ask me later, we'll tell you. But if that 99.9 has to go to 99.99, 4 nines, which is actually bringing down 43 minutes to 1 minute, let us say, right? You may have to spend few hundreds of hours of engineering effort, which is not worth it, because that the failure budget, right? You are actually allowing it to happen so that I don't need a perfect system, right? Because the perfect system is very expensive for me, while it doesn't give me so much of returns. So I can afford 40 minutes of failure rather than going for a perfect system of 1 minute. So I do a balance. In a scenario where 40 is recommended, I can actually go for 60 minutes also, right? 60 minutes of failure in a month, so that I can further cut down my engineering effort. There is a trade-off. That's what it means. So all these actually factors causing the curve to come down than the theoretical promise. Okay, how do we bridge? So these are certain practices which are causing certain delays. There is also a scenario where you have developer team, you have operation support team, and you have a SRE community, SRE team also in the whole organization. Now you have let us say a scenario, and you have a failure scenario. You have all got together, you fix certain things, you have done the firefighting, you have also noted certain action items. These action items are supposed to be closed. By who? All these things. Rarely it happens that you go back to the action items, start tracking them, and actually implement them, because you are actually ready and busy with the next sprint. So what is happening here is those action items get piled up. The system continues to be more manually managed than automatically managed, the way SRE prescribes. So what is happening? What we are prescribing as a best practice is every team, let it be the developer team, let it be the SRE team, also operation team. How do they look at giving a 20% of effort towards closing the previous action items within the sprint? So there is a prescription of at least allocate 20% of your time to close the technical debt. We call any problem that happens, anything that gets manually addressed, we can call them as technical debt. So give 20% time to make sure your technical debt is addressed in every sprint. So likewise, log the deployments. Okay, rarely it happens that there is an error budget burnt out completely. But are we stopping the deployments? There may be a critical feature that gets released for a particular seasonal sale, let us say. You cannot stop that feature from deployment just because you don't have error budget anymore. So the error budget gets overridden. So stop doing it. As a principle, if we stop doing it, we are actually promising, or at least reaching the promise of 100% balance between the velocity and stability. So these are the principles on which this particular promise can be potential, if not necessarily at 100% or 80%, from 50% to 60, 70 we can stretch, practically speaking, right? So that's the message from this. Now decouple the business growth to operational overhead. I was explaining that. How do we do it? We actually do the automation. We reduce the toil, and so it will lead to increased operational margin. So if you are actually delivering 10x scale of growth with not necessarily 10x growth on the operational expenses, but you are managing with 2x of operational expenses, then obviously you are leading to a lot more profitable business, right? So that way you are actually making sure your profit margins, operating margins are improved and through the automation. Now there are challenges. Theory says 100%. The best of the SRE organization says they are only 75%. Any cases, who is the best of the best SRE organization in this world? The father or the mother of the SRE itself, Google. Google can be perfect. They may be very close to 100, right? But there are other organizations who have stretched the limit and they have scaled themselves to the best of the SRE organization. They could only reach 75% in this case, correct? And most of the large other organizations are averaging at 45%. What does it mean? It means that there is still a toil. So what does 75% mean? Is that I am unable, even if the toil is said that if you already know the benchmark, 50% of your effort can go towards toil. But you can actually do a much better bargain on that and say that 30% is where I will limit my manual efforts in addressing incidents. Rest of them needs to focus on going back to engineering table and fixing through automation or systemic corrections needed so that the toil actually comes down. If this is the benchmark, how many organizations are reaching the target? They are unable to eliminate the toil at all, right? That is what this 50% means. Even if you are saying that 30% of my time should go to toil, these organizations are actually spending 60%, 70% of the time in the toil. That is what this metric means. Now what could be reasons? Reasons are automating the automation loop. Okay, you have done the automation, but automation itself is failing. Okay, you create another layer of automation for that, and you do a fix manually. You have to end up fixing the automation manually because you cannot create another layer of automation over the automation, right? So that is what leads to some contribution towards drop in the overall toil or increase in the toil. Second point is unknown unknowns. Known unknowns versus unknown unknowns. You don't know what you have to fix. What do you automate? Whenever a new feature is introduced, you don't know where it fails. What actually, the vulnerability in the system, you may not even know, right? The new scenarios might come up. A repeatable known issues can be automated. First time appearance of an incident, first time of its nature, you cannot really think of automating that, right? And it is not repeating. So you may have to end up, doing that manual fixes. So toil remains on that top. Diminishing return, So what happens is, over a period of time, the system is becoming stable and stable and stable. The edge use cases you will not be able to automate at all. Again, going back to the same, what is the effort you put into automation versus what returns you get, it may not equate. So you end up leaving the edge use cases as it is. So you end up continuing with the toil with it. So these could be the reasons. What could be the best practices? Okay. So maximize on auto remediation. So you don't need to really worry about those use cases which can be automatically remediated. Do that. So today, I think when this principle came up, there are not many matured observability platforms. So but today I think most of the tools have the auto remediation features built in. The AI is also helping in addressing this area. So which means that this is more or less taken care of in most things, and that is what also contributing minimizing the toil. Mandate the declarative infrastructure. This is what infra as a code. So can you mandate every single element? Let it be a network component, storage component, DB component, or infra component. Anything can be driven through code. Yes. In the world of cloud, yes. In the world of on-premise, virtualized, yes. But most of the organizations have legacy systems. Can you really do that in the legacy systems? It is difficult. So you continue to modernize the legacy, transform them into modern infrastructure, drive through code, so the SRE principles can be more relevant there. Build self-service. How many times you end up doing the service request fulfillment in a manual way? There are definitely a certain amount of service requests which we end up, because information from the self-service portal or the help desk, right? It will be half-baked. I want this, but you never specify what exactly it is. Okay. Now you end up calling them, understanding what is the requirement, then map the how to fulfill that service request, right? Or even if you have a template, the template is incorrectly filled. So these are the things which will lead to you're not able to automate all the service requests. Now look at how these can be addressed, making sure the templates are tight, the validation checks are in place, the users are empowered, or also translated. Okay, I need to rush. So that will actually help in automating the service requests also. Then enforce the toil deficit threshold. What it means is automated toil deficit. Toil deficit is basically how you are consuming or how your toil is controlled and managed. So you are not, how many times you actually get to measure the toil. If you have done an activity manually, do you record the time, how much time you spent? When you don't even record the time, right? How do you even say my toil is 20%, 30% or 80%? So that's where the challenge is. So how do you really, how the system-wise, you can track the manual effort given by the operational engineer. Those things can be seen so that these improvements will help in improving or addressing the toil part. Business aligned observability. This training we spoke about the definition about. How do we address this? We address this by defining the SLIs and SLOs. And this will lead to sustained customer experience. Okay, so by making sure, so the SLO is telling me that the customer experience has to be measured. But what are we measuring in the system parameters? How are these getting translated or converted is the biggest gap in terms of dropping the customer experience. So how the observability systems are making sure the business context is captured is the key of improving the SLIs and SLOs. Now what are the reasons? Engineering silos. Okay, somebody is developing the feature and somebody else is defining the SLO. Do they understand each other clearly so that you can expect or measure the SLOs or define the SLOs properly? Tooling limitations, yes, I want to measure certain thing, but tool is not giving me the data. Like I said, how to measure the toil, right? The tool limitations will lead to imperfection in terms of defining the right SLOs. And lack of context, all we spoke about it. Now bridging the gap. Re-engineer the SLOs, revise that, it's not that once you define the SLO, it is defined forever. You come back because new features added, new functionalities added, it might introduce a new defined parameters for the users to be measured upon. Telemetry with business context. Okay, this again, I think today's world, most of the observability systems are capturing the business context to that extent also, and they're also doing the log traces and all these things they are analyzing, giving you the business context to that also. Okay, so this will help in improving the observability part of it. Safeguarding from revenue, deployment losses. This is the canary deployment. Okay, so you are putting a limit to your impact radius, and then you are making sure your risk towards failures is limited within a confined region, and thereby you are allowing the innovation to start freely or risk-free innovation to flow into the production, right? So that is what it helps. The challenges are in terms of change failure rate. Okay, if currently okay. So currently the change failure rate at enterprise is very high. So how do we address this? Architectural guidelines for instant rollback. Okay. So any architecture that doesn't support instant rollback, you need to actually stop, releasing that. Okay, advanced telemetry to lower the, to detect. Even the failures need to be detected even within the confined region. If you can find the telemetry solution to detect the failure early, you can also limit the, the deployments, etc. Now the last point is about blameless culture. This is more cultural, nothing so much technical, but there are definite, points. In the interest of time, I am skipping this. But it actually leads to how the postmortems can be better addressed. What language should we use? Are we looking at the person who is in charge for the failure? Are we looking at the system? What in the system has allowed this failure to happen? Instead of saying that who has done that, right? I think this topic is also touched upon in the panel discussion. So who has done that is a question which is directly pointing or leading towards a blame. Versus you ask a question, what in the system could have avoided this, or what in the system has made this failure to leak? Okay, so these kind of language changes, cultural changes, or adoption will help in leading towards better postmortems. I think that's my last slide. What is the takeaway? Takeaway is that reliability framework is not only the theory, it also has to be aligned to the reality and the practice. So don't get carried away with your firefighting, backdrop. Yes, that happens, but it is important that even in the firefighting scenario, you come to a conference room, sit down and look at what and why it has. Thank you so much. If you have questions, I have time to answer questions. I can do that. I will answer to your questions.
Let's hear it once again for Chakravarti Komarolo. Chakri, that was really fantastic, and that's a kind of perspective that only comes from experience. So yeah, thank you so much again. Okay, there's one thing that's different today. AI is no longer just something we talk about. It is no longer just something that we experiment with. It's slowly becoming part of how we build, operate, and manage systems. And that brings us perfectly to our next session, because our next speaker is exploring a fascinating question. The title is, what happens when AI stops being just a tool and starts becoming part of the team? Okay, our next speaker, Satpal Singh, works at the intersection of cloud, AI, and observability, a place where things are either running beautifully or creating a very interesting incidents. He's passionate about building smarter systems, automating operations, and helping engineers spend less time troubleshooting and more time innovating. Today, he will show us what happens when AI starts joining the SRE team. So ladies and gentlemen, please put your hands together for Satpal Singh. Sat Shri Akal Satpal ji. Hun manch tuade hawale hai.
Thank you so much. All right, yeah. Very good afternoon to everyone. Good to see such a huge crowd. Yeah, it's really amazing how Hyderabad tech ecosystem has evolved, and thanks to our communities, who have come together, and thanks to the SREday organizers, and whomsoever is behind it, the volunteers, the community leaders, and the ideas of whomsoever has staged, and great to see such crowd. So welcome all to this big day, the SRE Day. Right. So I'm Satpal Singh. I'm an AI cloud and observability architect. This is my website. So I'm a Grafana champion. I'm a certified Kubernetes application developer as well. I architect, I just architect things. Yeah. Alright. So you can just go here. You'll find my socials as well. The LinkedIn and other community stuff I'm doing, right? Okay, now the word SRE, right? I know many of our speakers have asked how many of your SRE here, so I counted them. Okay, right? So good to see the turnout. And now when we talk of SRE, the mindset which I have seen about the role from the enterprise or in the startups, right? So most of them understand it as a support role, but for me it's not a support role. It's an engineering culture, right? So the SREs are the reliability engineers. They are actually the ones who maintain the reliability and the observability of the system. Without which we all know that, right? Without observability or reliability, there are no insights of the system. So we are the warriors. Yeah, the SREs are the warriors, right? So today's talk. Let me just switch to. I'm not a PPT guy, okay. So when I started looking at the roles of the SREs is actually looking at these roles. What does an SRE do, right? And there were a lot of talks about creating agents, right? How the SRE can be transformed into agents. What can agents do, right? So it becomes very complicated when we talk about agents, because it's not so simple as such, because we have worked for years in the role, we have got that expertise, we have that engineering culture, but how would you give that to AI, right? Okay, now let's consider a scenario, right? Let's say it's a production incident. Okay, we all know, right? Major incident manager, yeah. So major incident manager is the orchestrator. I hope you are able to see this, right? Yeah? You are able to see clearly? No, not clear, right? Okay, it's a bit dark. That's fine. So these are the agents actually running behind. Okay? All these are agents. There is an orchestrator agent here. This one, right? So when we talk about a production incident, MIM, the major incident manager, is the orchestrator, right? You all agree with me? Right? The person is the one who gets the SMEs on the call, right? War room. So this is the agent war room, let's say, yeah. And each of the agent is an expertise here. One is Kafka expertise, one is Redis expertise, one is has got the application context there, right? So think of this scenario: we have a war room, and we are trying to resolve an incident. There is the manager, the MIM, trying to run through the traces of the incident and understand, right? Okay, you get the context. You give me from app side, you give the context. From Kafka, you tell me what has gone wrong, right? That's how we try to solve an incident, correct? Right? Now, how you will try to give that intelligence to the agents, right? So each agent here has its own purpose. So there's Kafka SME, there is Redis SME, there is app runtime SME. We have got K8s agent as well, right? So we'll also see a live alert. Now I'll trigger a live alert, and we'll see the flow of how the orchestrator will actually contact these agents, get the context, and assign it to an appropriate agent as well, right? So the flow, right? I was talking about it. Think about it, right? So everyone doesn't know about all the technical products, right? So we try to bring in observability expert to run through the metrics, logs, and traces to understand what could go wrong. How to read the traces, maybe how to analyze the logs related with traces, right? So we have got observability agent as well. Okay, so orchestrator takes care of it. So it's a multi-agent orchestrator model. right? To tackle the complex systems, okay? And if you try to create a single agent, and give the expertise of all, right? Believe me, it's not going to happen. It's very, very difficult. So you need to create small agents. I'm just giving you an idea how to actually tackle the, when we design an agent, right? What are the things you need to have as a checklist? Okay. The first thing is the purpose of the agent. So many are creating so many agents, but they don't know what's the purpose of creating that agent, right? What are the problem you're solving, right? So I came up with this model because I've been seeing that the incidents, right? When we run through the incidents, the problem we were facing was either we don't have skills. I mean the SME, maybe he or she might be the SME, but we don't have the right skills. Okay, because we need to get ourselves updated every time, right? Because Kafka has got its own releases. Redis has got its own releases, Kubernetes has got its own releases, right? Maybe at that moment, that person might not be knowledgeable enough on that feature, right? Are you with me? Yeah? Right? So these are some of the challenges that we face when solving an incident, right? And I think industry is looking more for how to create agents in this space, SRE space, right? So I have come up with this model that I understand how, as a human, right? So we tend to do this, correct? We get the SMEs, we try to correlate, correct? The information from Kafka SME and then the application SME, right? And we try to correlate it. What does Kafka has to say? I mean, the Kafka SME has to say about this incident, right? And then from application point of view, is that correct or not? And is it applicable or not, right? So here comes the skills. Here comes the guardrails as well, right? The agent should be designed specifically for that reason only. Kafka cannot do the K8S job, right? As in, we have SMEs sitting here, right? And not everyone is an expert in Kafka. Not everyone is an expert in K8S, right? And if I try to pull up someone and say, can you solve me a problem on K8S? No. Then what you can do, right? Maybe Redis, that's okay. So you can solve a problem for me that I'm facing in Redis. That's your expertise, right? Maybe someone have expertise, in more areas. That's fine, okay. But again, you need to design the agents as a purpose, not just to simply design or expect that a single agent can do all the jobs. Again, it will throttle. When you have n number of requests hitting to that agent, it will throttle. It will just go off, right? So orchestrator takes care of it. Orchestrator actually has designed in a way where it understands the incident traces, assigns it to the appropriate agent, and then gets the feedback from that agent, and then it try to assign. But in the back end, right? It's LLM that does the job for us, does the reasoning for us, right? Choose the right models. Okay, I've used Opus 4.8. That's the best. I've tried others as well, but yeah, Opus 4.8 has given me a good result. Because considering the complexity of the system, right? How an orchestrator actually takes the decision, right? That's how, as a human, we also do. Correct? As a human, you also pick up. I mean, just for example, right? I was talking about a production incident, MIM, major incident manager. How does they run through, right? So we all have experience, in our jobs, right? Somewhere we run through a problem, we don't know, we contact our senior or maybe our manager to understand the issue, correct? That's how I try to design the entire this project about SREday. So let's see. It is not much clear. I'll just try to zoom in. You see, these are designed for the purpose. So this Kubernetes agent, this runtime agent, this Kafka agent, this Redis cache agent, database agent, no dependency, the correlation I was talking about. Now collect the information from the agent and correlate so that you go forward and it also ranks. How many of you know ranking? What does the ranking mean? Okay. You have mic?
Is that based on the links or what are the sources that are there?
Right. So, can you give me with an example?
Let's suppose take a blog which have more number of likes or more number of reactions on it, so it will rank it according to the which you are wanting.
Exactly. Right. So, here the logic is Kafka says yes, there is an issue in Kafka. Kafka agent says it. Right. And I've also given a brain to it. In simple terms, I'll explain. What is a brain now. The brain, so let's say I'm into an incident management, right? And then there is an incident came up. Now, as a human, what we do? We think of, okay, whether I have solved this problem earlier or not, isn't it? Right? That's the first thing you always do, because when you know that you have solved this problem with these commands, you immediately try to run those commands and solve it. Correct? What's that? That's your brain. Right? Now, second thing is I have also implemented a RAG pipeline here, which actually checks the existing incidents. That's what we do. Correct? So we have incident database. We go and check the incidents, previous incidents, whether the same type or kind of incident has already been occurred. Check what was the RCA done, try to resolve it, right? So both have been given here, memory, the brain basically, and the RAG pipeline, wherein we have the incident stored, right? It also does the remediation that we will see in the live execution. There is one, you can go for to create a GitHub issue. You can integrate with Slack, right? Create an incident channel, and then all of the SREs can come and just look at the incident, what's happening, right? And at last, human in the loop. Okay, so we all know, right? We can't trust AI, right? Correct? We can't trust AI. That's the truth. So I have kept an approval step after the remediation, or after the diagnosis, right? So it will give a summary. You will definitely see that. It will give a summary. It's upon us whether we approve it or reject it. If we approve it, it straight goes to the vector DB, which means we are persisting it. We are agreeing, yes, these steps have solved the problem, and we are persisting it in vector DB, right? What as a human, what we do? We write it in a conference page or wiki page, isn't it? We store. We persist somewhere, right? For us to when there is a similar type of incident, your brain will actually understand that. All right, back in the memory, this has been solved earlier. Go refer the wiki, right? And go refer your incident database, right? So I hope now you are understanding the complexity, right? How a production incident is triaged, right? So these are the scenarios. These are the scenarios which needs to be considered when you design an SRE AI agent, it's not only infrastructure, right? So the apps, infrastructure is fine, like, we have KTS events, collect the events, triage it. But again, if you don't have the memory, if you don't give the context, LLM will come up with a new response every time. Classic example, there is a release happened today in K8s, right? And the docs were updated. But in production, right? Of course, right? To go into production, it might take a week or two, maybe, considering your how quickly is your release management process. But the release version in production is one version behind. Of course, right? When there is a release today in Kubernetes, you can't expect your production to have the latest release, right? Now you have run through something on the production. Imagine there is a deprecated API, and then the LLM says, all right, so you have got a deprecated API. Now, as a human, how would you judge this? How would you judge this? So your LLM, your AI agent says the API is deprecated, but you go and check the release page, that's the current version in production, it says, no, that's intact, that's the feature of that version. How would you tackle this? Again, setting the purpose of the agent. Kubernetes agents should be designed in such a way that it has skill, it has guardrails. So the purpose of that agent should be which version of the documentation should get preferred. That's how it works. That's how agents work. You can't go and say in Instagram we see, right? In 2 prompts you get a website. Maybe you through Cloud you have a connector in a single prompt. That's what is happening. But no, that's not the case. AI can't really help you out in terms of designing a system, because as a human you need to design a system first. Give a purpose to that agent. That's how it works, right? So there is so much to it. Each agent has been designed in such a way that it doesn't move around, apart from what is being designed for it. Let's say Kafka, it does the only Kafka job. It's a Kafka assembly, that's it. Right? So we have got postmortem agent, which actually writes the RCA. Then the learning, of course, it goes back to the memory here. Right? Okay. Here is the brain. I think the screen sharing is a bit lagging, but you see the brain, this is the brain of the SRE. Right? So each of the blue dot, I'll just try to zoom in. So risk engine is one of the service. So these incidents are created around this risk engine, which ultimately stores somewhere. Because if I run through, if there is an alert next time, it refers to the incidents and understands, alright, so this has been solved already. The steps can be used as is, right? But at last, there is human in loop. Human should approve the diagnosis and the remediation steps, which means you as a human are agreeing that, right, these are the correct steps to solve the incident. And remember, these, again, whatever you approve goes to the memory, right? So if you are wrong, agent is also wrong. As simple as that. Right? So this is a brain. You can see there's a lot more to this. This is one of the surveys just to show you guys, right? I was running constantly on the risk engine, sorry. So that we see n number of incidents here. Right? So this is the rack pipeline I was talking about. Let's say if I go to OM, so it will tell me OM kill related incidents here. So this is a rack retrieval pipeline. So this is a rack pipeline, right? So we have seen the brain. I just try to depict the architecture here. Okay, how it works. So with alert manager, you can send alerts to the orchestrator, the Kubernetes events, on-call console. Like if an on-call person gets it, even you can manually enter the data and trigger the pipeline. Right, the Kafka broker as well, Prometheus. Okay, so there should be always a gateway to for security purpose, and then it comes to orchestrator, and I have used event bus so that all the agents can be fan out at a time, because that's what we need to do, right? The same example, production incident. We are in a war room on a call, right? So the manager asks everyone, this is the incident, just look at your logs. Isn't it? Okay? Right? Okay, so I'll just run a live incident here, because it's already run. Let me just try to run a live incident for crash loop Kubernetes. Sorry. Alright. Let's see how does the agents actually fan out, and know which agents are getting touched in live. Alright, you see, it has touched Kubernetes, it has gone like runbook. So this is the runbook agent. It has gone to the Kubernetes, right? Okay, my bad. This was a mock. Let's go for actual LLM. It will not take much time. So I'll actually, we'll see the actual reasoning now, or maybe the live incident. Alright, now let's see. So it has first checked the runbook, the memory. Now let's see what exactly it does. Alright, it has checked the database, nothing much there. Redis, not. Alright, so it has gone for Kubernetes. It understood that this is something related to Kubernetes, crash looping, right? And then it does the investigation, and here is your war room timelines, right? What happened, right? It went to the runbook agent, one applicable runbook found, right? Memory, strong memory to incident, because there are likely some reoccurrence of the same issue, crash looping. This entire, war room timelines gives you, what's happening as we see in a production incident call, right? In the same way, it lists out the steps. And there goes the diagnosis and remediation and approval. What it says is rolling restart has worked 2 out of 2 times for this signature, so 100% success. So that's the level of confidence, the ranking which we were talking about, right? And then once I approve, it logs it, right? It's my name. See, its audit rate is also there, that who has approved. So incident resolved, right? So this is what a live, incident looks like, and I have tried to, replicate it with the multi-agent orchestrator model, right? I hope you guys followed and understood. Okay, again, I'm not a PPT guy, but I tried to explain it through the agents, right? Live demo. Hope you all understood and something to take away from this, right? So my time is up. So thank you so much.
Well, thank you so much, Satpal. That was truly an insightful session. And ladies and gentlemen, with that, we are done with the first half of the event. And actually, I feel like while looking at today's event, maybe the ensemble of speakers and a lot of amazing sessions, it feels analogous to movie Dhurandhar. How many of you are fans of Dhurandhar here? Lot of stars, and each and everyone has a unique story and unique character, right? And similarly, even here, It is an event with lot of communities, lot of leaders joining in. And Vinay and SREday Hyderabad team is giving us a truly an Aditya Dar vibe. Just how he got an amazing celebs all in one frame. Today, Vinay and entire team of SREday Hyderabad got the best speakers in Hyderabad. So let us hear it out for our Aditya Dar, Mr. Vinay. And also Sapal, he's giving the Dhurandhar vibes already. जैसे जसकिरण सिंह जो है वो लियारी की बादशाह है, वैसे हमारी सतपाल तो ऑब्जर्वेबिलिटी बादशाह है. And what you've seen till now, it's just like Dhurandhar, and what you're going to see after the lunch, it's going to be Dhurandhar the Revenge. So we have amazing lineup of speakers. Yeah, we have speakers, amazing lineup of speakers joining with us. So enjoy your meal, have a great time networking and connect with your peers, and see you back after lunch. And once again, thanks to Muskan and Siftaj. That was an incredible hosting. Thank you all once again. Join you after lunch. I request everyone to leave from the behind doors. Don't use side doors. Leave from behind. Everyone are requested to come back by 2:15.